So now we're going to talk about the power theorems in this chapter. The power theorems focus on the segments in a circle. And the way I like to teach this is I like to talk about the power of the point. The power of the point looks like this. Okay, it's kind of weird. Point to circle times point to circle equals point to circle times point to circle. And if you want to pause the video to write that down, this would be a good time. Okay, so it's kind of confusing, but hopefully I can make some sense for you guys. We have three situations. We have a situation of chord, chord. We have a situation of secant, secant. And we have another, so chord, chord, secant, secant, and we have another situation of secant and tangent. And for each of these, you're going to be focusing on the segments, not the angles. I'm going to put some letters in here. So when I talk about the power of the point, in this example, it's where the chords intersect. So this would be my point. And you can see I'm going to follow this right here. Point to circle times point to circle. And you're going to do one chord at a time. So if I focus on this chord, start with the point and go point to circle, CA, point to circle, CD, equals, now go to the other chord, point to circle, CE, point to circle, CB. That's your first theorem. In this second example of secant, secant, put some letters in here. Power of the point, the secant and secant intersect at this point. So that's my power point. One secant at a time. Point to circle, AB, times point to circle, AC, equals other secant. Point to circle, AD, point to circle, AE. And finally, in this last example, we have a secant and a tangent, one at a time. Point to circle AB, point to circle AC, equals, switch segments, point to circle AD, do it again, point to circle AD, or AD squared. And these are your three power theorems. A couple of quick examples. If we look at this chord, chord example, not drawn to scale. Here's my point. I'm going to go point to circle X times point to circle 8 equals point to circle 3, point to circle 6. 8x equals 18, x equals 18 eighths. Next example, secant, secant. Here's my point. I'm going to go point to circle 8 times point all the way to the circle, 16, equals point to circle 6, point all the way to the circle, 6 plus 2x. All right, keep working this out. We get, I think this is 128, equals 36 plus 18x. Okay, subtract the 36. $92, and x is going to equal whatever 92 divided by 18 is. Last one, an example when you have a secant and a tangent. Let's call this x, this 4, and this 6. Here's my point. Point to circle x, point to circle, square it. Other side, point to circle 10. X squared is going to equal 40. X is going to equal the square root of 40. In algebra, this would be a plus or minus, but obviously x cannot be negative, so the answer is just the square root of 40, which is 2 root 10. Okay? These are just some basic examples. Of course, you're going to have to go and try some additional problems.